Algebra 1 students, here are your notes from lesson 5.8, graphing and translating absolute value functions. First of all, we need to know what an absolute value function is. You've actually used these when we've solved equations before, but we haven't looked closely at the graphs. But an absolute value function has a V shape. It can open up, as you see over here on the left when you have f of x equals the positive absolute value of x, or it could open down if you just put a negative symbol in front. We call that a reflection, but we can use either of these graphs as parent functions essentially. We'll talk more about what that means as we move on, and we'll look at how we would translate either of these graphs. Now we'll focus specifically on the positive version in our notes, but you'll see an example of the negative on your homework assignment in class. Not a big adjustment for you though. Alright, so a translation is a shift of the graph. It could be vertical or horizontal. It depends on where that number is that's changing it. So the translations of the absolute value graph are shown below. The first graph that you see here in blue, you can see the parent function, y equals the absolute value of x. Where the green graph, the only thing that's changed is we've put a plus 3. Now strangely, when you work inside the parentheses, a plus 3 actually moves the graph left 3 places. When you look at the next graph, the parent function is still in blue, the absolute value function. But notice we've got a minus 3, and a minus 3 inside the parentheses moves us to the right, strangely enough. So plus 3 moves us left 3 spaces, minus 3 moves us right. Now when we add or subtract outside the absolute value bars, it actually moves us vertically. So the first two were horizontal shifts. The bottom two you see here are vertical. So the first one, y equals the absolute value of x plus 3, just moves us up 3 spaces. Basically takes each point on the graph, just shifts it up 3. Where minus 3, not surprisingly, would move us down 3. So again, on all 4 of those graphs, the absolute value function, y equals the absolute value of x, is there in blue, and the functions in green, orange, purple, and black on my screen. I know in your notes it's hard to tell the difference between the colors, but on this, the colored versions that aren't blue are all the transformed, or translated I should say, graphs. Now I want to show you a site. I've shown this to you guys before, but this is the Desmos graphing calculator, and I will put this link just below the video, so if you click on the link below you can kind of play with this yourself as well. Now I've put all these absolute value translations into one graph. We're only going to move one of them at a time. Now C represents outside of the graph, so it's essentially our vertical change. So watch what happens when with the graph when I slide this. As I move to the right, you can see that graph move upward, and the further I move it, the further it goes. We can't even see it anymore. As I move to the left, now I'm at +1 and I'm at 0, so I'm back to the start. But as I move left, this graph moves down, probably what you would have expected. And I'm going to move that right back to 0. Now the horizontal shifts are a little different. This is b equals 0 currently, so I don't have any change in here. But watch what happens. When I move this left, the graph actually moves right. So when I'm at -6, in other words, this is the graph y equals the absolute value of x minus 6, it's shifted the graph to the right. Whereas when I move to the right, the graph moves left. So right now I'm at y equals the absolute value of x plus 5.1, and you can see that graph has shifted left. Kind of a cool little application, and again, that link is there for you. I would encourage you to take a minute and just kind of move those sliders yourself. Alright, now let's go to some more of the work here. These notes will be fairly quick, but let's continue on. The absolute value function is translated, write the new function. So again, when we say the absolute value function, we're saying the function y equals the absolute value of x. I'm a little sloppy with my notation there. Since it's a function, it technically should say f of x. I don't care if you use f of x or y. It's your choice. All right, so what I look at here on this graph, the original graph is down here on blue. The vertex is at the origin, and I notice that it has shifted up by 2 spaces. We've gone up 2. The way we do an up 2 with an absolute value graph is outside of the parentheses. It's the absolute value of x plus 2. That's all there is to it. Now on the next one, I can actually see this graph has gone to the right 5 spaces. We've shifted right 5. Horizontal translations are inside the parentheses, but remember, it's opposite direction from what you would maybe think, so minus 5 represents a movement to the right. All right, on number 3, you can see on this graph it's a fairly small change, but we've shifted left by 1 space. So our function to graph left 1 space would be y equals the absolute value of x plus 1. Again, horizontal means your movement happens from inside the absolute value bars, and left is when you have a plus, and right is when it's minus. Okay, and then the last one here, it says it's shifted down 17. Okay, so again, that's a vertical movement, and the function then is changed outside the absolute value. It's minus 17 out here. So y equals the absolute value of x minus 17. Again, the key is horizontal shifts are inside the absolute value bars. Vertical are outside. All right, let's work the opposite direction. Let's actually create the graphs. Now, the parent function, it might not be a bad idea for you to start by graphing the parent function. I'm going to do that. That's the basic absolute value graph. It goes like this. We've talked about the V shape. What I didn't talk about earlier is that it essentially has a slope of 1 to the right and negative 1 to the left. So this is f of x, or just simply y equals the absolute value of x. Okay, so let's look at number 5. It says the absolute value of x minus 3. What I know that minus 3 is doing is shifting this graph down 3 spaces. So every point along the way would be shifted down 3. So I know the red graph here is number 5, and I'm just going to label it like that, number 5. Okay, on number 6, y equals the absolute value of x plus 7. I know this plus 7 right here is moving us left 7 units, or 7 spaces. So what I'm going to do is, again, go back. Parent function is here. I need to go left 7. That takes me to here. And the graph will look something like this. Now again, remember that just because my graph ends right here, it's really not the end. Technically, these extend infinitely, so if we were being real precise, we'd have arrows on the ends of these things. Okay, and then the last one for us to look at, y equals the absolute value of x minus 3. That minus 3 right there is moving us right 3 units. So I'll grab my line tool here, and that'll work. And so I start back at the original, and I move right 3. You can see we're going to have some overlap on that side of the graph. Over here, it'll be a different story. But our graph should look something like that. Now, I forgot to label number 6, but that right there is number 7, and the one in green was number 6. And the other thing I noticed that I neglected as I worked through the problem, I didn't label it the same as the others. On number 5, we talked about it, but I didn't write it down. That -3 is a shift down 3 units. I think you guys knew that anyway. All right, I hope you understand what's going on here. If you have any questions, bring them to class on Friday, and we will go from there. Have a great day.